Here we have a sample problem for Module 4. Here we have two blocks A and B on a frictionless surface shown in the figure are connected by a cord of negligible mass over a frictionless pulley. Letter A, draw an FBD of each block. Letter B, find the mass of block B as it slides down the plane that keeps the system moving at a constant speed. Letter C, find the tension in the cord. Letter D, repeat A to C, but this time there is a presence of friction with the coefficient of kinetic friction UK equals to 0.2. First step is to draw the FBD for each mass. Here we skewed the angle of the Cartesian coordinate system, while maintaining the orthogonal relationship of the x and y axes. The x-axis is of the same orientation as the surface of the where the blocks are placed, and this is done so that we can simplify the FBD. For mass A with the value of 10 kilograms, we see that the tension force is on the positive axis and the normal force exerted by the surface onto the mass is on the positive y-axis. For the weight of mass A, it is lying on an angle 30 degrees with respect to the negative y-axis, thus it is broken into its components along x and y-axis such that its weight component along x is on the negative x-axis and its weight component along y is on the negative y-axis. Similarly, we repeat the same to mass B of unknown value. The next step is to write the sum of its forces along its axis. For mass A, the forces along x are the positive tension minus weight component along x equals to mass A times acceleration. Note that the speed v is constant according to the problem, then the acceleration, which is the rate of change of velocity over time, must be equal to 0. So the sum of forces along the x-axis is simply tension minus mass A times g sine of angle theta A equal to 0. For the sum of forces along the y-axis, it is the sum of the normal force minus weight component along the y-axis equals to 0. 0 since there is no movement along the y-axis. This is further expanded into the normal force A minus the mass A times g times cosine of the angle theta A. For the unknown mass B, the sum of forces along the x-axis is equal to the tension minus the mass B times g times sine of the angle theta B equals to 0. For the y component, it is the sum of the normal force B minus the mass of B times g times cosine of the angle theta B equals to 0. The third step is to use the ideal equations to solve for the unknown. Here mass MB is calculated by using the equations obtained earlier and substitute them to determine an expression for the unknown. MB is equal to the ratio of the mass A times g times sine of theta A over g times sine theta B. The value of mass B is approximately equal to 7 kilograms. Here the tension is calculated by using the equations obtained earlier and substitute them to determine an expression for the unknown. The tension is equal to the mass B times g sine of theta B. This gives us the tension approximately equal to 49 newtons. For letter D, the problem introduces the presence of the friction, or more specifically kinetic friction. Going back to step 1, we redraw it such that the friction force is added onto the FBD. Recall that the friction force opposes the direction of the block, so for mass A it is on negative x-axis and for mass B it is also on the negative x-axis. Rewriting the sum of forces in order to incorporate the presence of the friction, the sum of forces along x is the only altered, and so it becomes the sum of the tension minus mass A times g times sine of theta A minus the coefficient of kinetic friction times the normal force A equals to 0. Also for mass B, rewriting the sum of forces in order to incorporate the presence of the friction, the sum of forces along x is the only altered, and so it becomes the sum of the tension minus mass B times g times sine of theta B minus the coefficient of kinetic friction times the normal force B equals to 0. The third step with the presence of friction to calculate for the mass B is done by using the ideal equations obtained earlier. We get that the mass B is equal to the ratio of mass A times the quantity sine of theta A plus the coefficient times cosine theta A over the sum of sine theta B plus coefficient times cosine of theta B. Here mass of B is approximately equal to 8 kilograms. The end for now. For questions and comments you may send them to diyeslearningstuff@gmail.com. You may review the slide on YouTube at @dies_learningstuff. Note, please do not forget to use your school email. Also write your complete name and class section. Thank you for listening and see next meeting.